Alright, now let's look at what we have here on the board. We are asked to differentiate the following functions with respect to x. Now, this is the first function, y is equal to 3x squared plus 4x minus 6. Second function is y equal to 5x cubed minus 2x squared plus 9x plus 10. While the third function is y is equal to open bracket 4x plus 5 close bracket all raised to the power of 3. Now, this is very, very simple. I must promise it's very simple, but this is what you need to do. When you want to differentiate any function, the type of function you see determines the approach you use to differentiate them. What this means is there is a type of function I will see and I will differentiate in another way. And there's also a type of function I will see, I also differentiate in another way. But meanwhile, all of this we are going to abide by their rules. You get? So now the first question we have here, uh, we have y equal to 3x squared plus 4x minus 6. Now, this is the solution on how to solve this. We have y equals to 3x squared plus 4x minus 6. Now, there is this rule of differentiation of which I will introduce to you. That if you have a function y equal to x raised to the power of n, this is the function y equal to x raised to the power of n, our dy over our dx is equal to n times x raised to the power of n minus 1. What this means is this n, which is the exponent, will now multiply the base, the exponent or the power will multiply the base, and you also subtract 1 from the power. That's what the rule stands for. So anytime you have a function y equal to x power n, just as we have y equal to 3x squared, this 2 stands for the n, yx stands for 3x. You get? So anything at the top here is known as the power or the exponent, while the base stands alone here. So what you do is you use the power to multiply the base. So dy over dx. Dy over dx means you're differentiating it. It also means you're looking for the derivative. It also means that you're looking for the differential coefficient. You're looking for the slope. All of it means the same thing. You get? So the n now multiplies the base x and then you subtract 1 from it. So for example, if I have a function x squared, for example, if I have a function y equal to x squared, my dy over dx will be equal to this 2 we multiply x, and I'll have 2 times x raised to the power of 2 minus 1. 2 times x will be 2x. 2 minus 1 is 1, which is the same thing as 2x also. If you put it, leave it like this, or you leave it only on 2x, you're still correct. You get it? So now let's apply these rules into the question without wasting much time. Now we know that our dy over our dx will be equal to this power we multiply the base, just as we have said. So we'll have 2 times 3x raised to the power of 2 minus 1 plus, here is the power of 1, is power of 1 at the top there. So this will give us 1 times 4x raised to the power of 1 minus 1. You get minus, now the derivative of a constant is 0. The derivative of a constant is 0. For example, if I have a function y equal to 5, my dy over my dx will be equal to 0. If I have y equal to 100, my dy over my dx will be equal to 0. Any number at all, even though y is equal to 1 million, as far as it does not have a variable attached to it, it is regarded as a constant. and the derivative of a constant is equal to 0, or dy dx of a constant is equal to 0. So the derivative of 6 is what? 0. That's it. Now my dy over my dx will be equal to, these two will stand remaining. That will give us 3x raised to the power of 2 minus 1 is 1, plus 1 times 4x raised to the power of 1 minus 1 is 0, minus this 0 here. So my dy over my dx will be equal to 2 times 3x will give us 6x, plus 1 times 4. Now x is raised to the power of 0, and we know that in indices, a number raised to the power of 0 except 0 itself is equal to 1. Any number apart from 0, any number at all apart from 0, and that same number is raised to the power of 0, that number is regarded as 1. So it will be 1 times, x raised to the power of 0 is 1. So 1 times 4 will be 4 minus 0. So my dy over my dx will be equal to 6x plus 1 times 4 is 4 minus 0. 0 can just stand alone. This is the solution for the first one. Now for the second one, what we have is y equal to 5x raised to the power of 3 minus 2x squared plus 9x plus 10. Now, same thing applies here. This is just the solution to this. We have y equal to 5x raised to the power of 3 minus 2x raised to the power of 2 plus 9x plus 10. Now my dy over my dx will be equal to, this power will multiply the base just as usual, just as we were doing in this previous example. So 3, this will be 3 times 5x raised to the power of 3 minus 1 minus 2 is here. So 2 times 2x raised to the power of 2 minus 1, 2 minus 1 plus, there's an invisible 1 here. So the 1 will multiply the 9x, 1 times 9x raised to the power 1 minus 1. And then we know that the derivative of a number, or the derivative of a constant, is what? 0. Now our dy over our dx becomes 3 comes down times 5x raised to the power of 3 minus 1 is 2, minus this 2 comes down times 2x, 2x raised to the power of 2 minus 1 is 1, plus, now 1 comes down times, now 9x raised to the power of 1 minus 1 is what? 0. Now, we can bring that 0 and also leave it out. Now, our dy over our dx will be equal to 3 times 5x squared will be 15x squared minus 2 times 2x will give us 4x. Now, just as we said, any number apart from 0 that is raised to the power of 0 is equal to 1. So 9x, x raised to the power of 0 is 1. So 9 times 1 will give us plus 9. So this will be 3 times 5x will give us 15x squared. 2 times 2x will give us 4x, bring down the minus sign. 1 times 9 into 1 will give us 9. So this is dy dx for this particular function. Now, just as I said earlier, the type of function you see determines the approach you are going to use in solving it. Now, when we come to this type of function, the approach is going to change. Now, all you just have to do is stay tuned and make sure you subscribe to this channel. If you're seeing me for the first time, subscribe to this channel. Follow us on all social media platforms so you will be notified when we drop the answer to this last question. See you next time. Thanks for watching. Bye.